In this video, I'm going to review how to find the solutions to the quadratic systems using the completing the square method. So the first thing I'm going to do is I'm going to locate the constant and I'm going to move it to the opposite side. In this case, I'm subtracting 24 from both sides. And in that blank space, I'm going to leave a line. 0 minus 24 is negative 24. Now I want to get a perfect square, so I need to fill that position with just the right answer. How do we choose that answer? We take whatever the b value is, including the sign, you divide it by 2, and you square it. Negative 14 divided by 2 is negative 7. Now when I square it, negative 7 times negative 7 is a positive 49. We need to keep the equations balanced. Whatever I do to the left, I must also do to the right. So I'm going to add 49 to both sides. Okay, let's go ahead and let's factor the left-hand side. X squared plus 49. And when I take negative 24 and add it to 49, I get a 25. How do we factor this? Okay, what multiplies to equal positive 49 and combines to equal negative 14? So they're going to be the same sign and both negative. And that would be negative 7 and negative 7. Multiply and combine. So negative 7x, negative 7x. Okay, keep factoring here. Factor by grouping. I can factor out a 1x, and I'm left with x minus 7. What number times x equals negative 7x? And negative 7 times negative 7 is, in fact, a positive 49. Now, the front and the back both have the quantity x minus 7. In front of the first is a 1x. In front of the back is a minus 7. And now look at, I have the exact same thing. So I've just factored, I have the exact same thing. I've got a shortcut I want to share with you. Another way to get this rewritten expression on the left-hand side is to do the following. After you've identified what is negative 14, the b value divided by 2, after you identify this numerical value, I'm going to include the sign and put it after the x. That's the exact same thing. I have two quantities of x subtract 7, and I'm going to set it equal to 25. Okay, so now I need to solve for x. Opposite of squaring something is taking the square root, and as a quick reminder, this tells us we're going to have two answers. On the right-hand side, I put a plus or minus. The square root of 25 is 5. And now to isolate the x, I have to add 7 to the opposite side, and it's going to sneak in front of the plus or minus. So 7 plus or minus 5. Now they're the same type of number, so I can go ahead and go 7 plus 5 and 7 minus 5. One answer is 12, the other answer is 2. If I took these two solutions, one at a time, and I plugged them into the original equation, so 12 squared minus 14 times 12 plus 24, the left side would equal the right side. Both would be 0. If I took 2 and I plugged it in to the left-hand side, 2 squared, subtract 14 times 2 plus 24, the left side again would equal the right side. Both would have 0 equaling 0, which is a true statement. As a reminder, if I go back and I change this quadratic equation into a function, so if I wrote down y equals x squared minus 14x plus 24. So I took the equation and changed it into a function and I graphed it. Guess what? These two solutions would actually on the graph be the x-intercepts. And other words for x-intercepts would be solutions and roots. Let's look at example number 2. Example number 2. So the first thing I'm going to do is I'm going to take this value, move it to the opposite side. X squared plus 6x equals negative 8. Now I'm going to take whatever that b value is, and I'm going to divide it by 2 and square it. So 6 divided by 2 is 3, and then I square it. 3 squared is 9. Plus 9 and plus 9. Whatever I do to the left, I must also do to the right. Negative 8 plus 9 is positive 1. Now over here, I could go ahead and factor. I want to show you that again. I could go x squared plus 9. Okay, make my x, so 1 times 9 is 9. Adds together to give you 6. That'd be 3 and 3, because 3 times 3 is 9. 3 plus 3 is 6. So plus 3x plus 3x. And you can see that I would factor this to get x plus 3, and plus 3. Yep, there's 3x, and there's 9. Okay, it works. And what would we get? We'd get the quantity x plus 3 times the quantity x plus 3. But there's a faster way that results in me not taking time to factor. We chose this number for a reason. We selected this number so that we would get the same quantity twice, and that will work every time. So I don't have to do all this if I don't want to. There's a shortcut. I can take whatever this value is and do x plus 3 in this case. Will it always be addition? No. Sometimes this will be subtraction like we had before. I set it equal to the quantity 1. Okay, let's solve for x to find the solution. I'm going to have two answers. On the opposite side, I put a plus or minus. The square root of 1 is 1. Now let's isolate the x. Minus 3, minus 3. So I have x equals negative 3 plus or minus 1. One time I'm going to add. One time I'm going to subtract. What does that mean? Negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4. These are my two solutions. If I went ahead back to this quadratic equation and I substituted negative 2 in for x, and I did the math on the left side, it would equal 0. Same thing, if I substitute negative 4 in the left-hand side, it would equal 0. If I took this and turned it into a function and I graphed it, guess what the x-intercepts would be? Negative 2 and negative 4. All right, let's go on to a more complex problem. Now, what's the difference with examples 3 and 4? Example 3 and 4 don't have a 1 in front, so it's going to be a little bit more work. I'm going to slow this down. The very first step remains the same. I'm going to take this constant, I'm going to move it to the opposite side. In this case, I am adding 16 to the opposite side. So I have 3x squared plus 12x, and 0 plus 16 is 16. Now, this is different from examples 1 and 2 because the leading coefficient isn't a 1. When there's a 1 in front, it's pretty easy. You've learned this freshman year. What do we do when that value isn't 1? Now we need to factor that out. So I'm going to take this value, I'm going to factor it out. 3 times 1 is 3, bring down the x squared. 3 times positive 4 is 12. Okay. How do I figure out that value? It goes back to exactly what we previously did. Now all I'm concerning myself with this is this trinomial that is inside parentheses. So again, we want to figure out a unique number here that allows us to rewrite it. We want to figure out this unique number that allows us to rewrite it. How do we do that? We take whatever the b value is, and we divide it by 2, and we square it. 4 divided by 2 is 2, and now we square it. 2 squared is 4. So in this position, I'm going to do plus 4. But I can't just do plus 4 off to the right. Notice that I added 49 to the right-hand side to keep the equations balanced. Because I added 49 to the left, I have to add the same value to the right. Because I added 9 to the left, I have to add the same value to the right. Well, why wouldn't I add 4 to the right-hand side? And here's the reason. We did not, in fact, add 4 to the right-hand side. We added a value of 12. So on the right-hand side, I have to add 12 to keep the left and the right side of this equation balanced. Okay, 16 plus 12 is going to be 28. Now I'm going to rewrite this. Now again, I could factor this off to the side, or I could recognize that the quick way of doing this is to write x plus 2. All right, so my next step then is going to be to solve for x. So how do I go about solving for x? I'm going to divide by 3, divide by 3. 28 does not divide by 3 nicely, so we're going to leave it as a fraction. And now to isolate the x, I take the square root of the left and right. Remember, this means two solutions, so plus or minus. And now to isolate the x, I'm going to move the 2 to the opposite side. It's always going to sneak in front. X equals negative 2 plus or minus the square root of 28 over 3. Now this isn't wrong. Here's my two answers. One time I add, one time I subtract. So if you like to separate them, you don't have to, but if you want to separate them, this would be one answer. If you want to separate them, here would be the other answer. Okay? These would be our answers, and we're going to talk about in our next lesson how can we rewrite things in a more proper form. But right now, this will suffice. Let's look at example number 4. So example number 4, the key is that the leading coefficient is not a 1. So I'm going to start by moving 6 to the opposite side. 4x squared minus 24x equals 0 minus 6 is negative 6. Again, whenever the leading coefficient is not a 1, I've got to factor it out. So I'm going to factor out here. 4 times 1 is 4. 4 times negative 6 is negative 24. And I'm going to focus just on this trinomial that's inside parentheses. This is my b value. So negative 6 divided by 2. Negative 6 divided by 2 is negative 3. And negative 3 squared is 9. So I'm going to put 9 into this open spot. But I did not just add 9 to the left. I actually added a value of positive 36. 4 times 9 is 36. So plus 36 to the right-hand side. 6 plus 36 is 42. And I have a fast way of doing this. Instead of taking time to factor it out, I'm able to write an x and bring this down, minus 3 squared. Okay, so I'm going to go ahead, divide by 4, and we're going to see can 42 divided by 4 be reduced? And it doesn't reduce very nicely, but it does go down to 21 over 2. Now let's remove the square. So square root both sides. This tells me there's going to be 2 answers, plus or minus. And now we're going to move this 3 in front. X equals 3 plus or minus the square root of 21 over 2. All right, lastly, let's talk about, let me move this back here and grab a new piece of paper. Although these answers, and let me do this in pink so it kind of stands out here. So 3 plus the square root of 21 over 2 and 3 minus the square root of 21 over 2. Is there a better way to write this? Algebraically, this isn't wrong, but is there a more proper way to write this? Let's talk about that next. So at the end of this video, we're going to go back and we're going to talk about examples number 2 or 3 and examples number 4. And mathematically, I haven't done anything wrong, but at this level of math, there's a way to combine these two and put it in proper form. So when using the square root of 28 over 3, we can break up that square root. All right, well, what are we going to do next? We do not want to leave any final answer with a radical on the bottom. So to rationalize the denominator, I'm going to multiply by both the top and the bottom of this second part of the solution. So this is my solution. The second part of the solution by the square root of 3. So 28 times 3 is 84. So I have the square root of 84. 3 times 3 is 9. So I know the square root of 9 is 3. Everything's looking good. I no longer have a radical in the denominator. Now I need to be able to push these together. So I want to combine this. So I need to have a common denominator. I'm going to go times 3 and times 3. X equals negative 6 over 3 plus the square root of 84 over 3. Now, negative 6 and the square root of 84 are not like terms. But so far what I've done works. Now let's see, can I break down the square root of 84? So you were provided this paper this week, and we can see all the perfect squares. Let's look at 84. 84 would be in between 81 and 100. So I'm going to go, okay, 84 divided by 81, well, that doesn't break down nicely. 84 divided by 64, and I continue to break it down until I find one that works. 84 divided by 36, 84 divided by 25, by 16, but when I get to 4, it works. I'm able to rewrite 84 as 4 times 21. So I come back here, and I rewrite this as 4 times 21. The square root of 4 is 2, and now this is in proper form. Can we do anything more? We could factor out 2 out of these first 2 terms. That's really not going to help us. There we go. So that are the 2 solutions to example number 3. Now let's look at example number 4. So this is what we ended with. We ended with x equals 3 minus the square root of 21 over 2. Is there a better way to write that? There sure is. So I'm going to break it apart into the square root of 21 over the square root of 2. And now I'm going to rationalize the denominator. So whatever the denominator is in this second fraction, I'm going to multiply the top and the bottom by the square root of 2. X equals 3 minus 21 times 2 is 42. 2 times 2 is 4. So I have the square root of 42 over, well, the square root of 4 is 2. Okay, let's find a good common denominator, which is 2. Now I have 6 over 2 minus square root of 42 over 2. Since I have a common denominator, now we'll push 6, subtract the square root of 42 in the numerator position, and 2 is in the denominator. Can I break this apart? Let's find the square root of 42. So 42 would be right here. Let's see if we can break it apart. Sometimes you can, sometimes you can't. So 42 are going to work your way upwards, divided by 36. 42 divided by 25. We're going to have a whole number if we're able to break it apart, and it's not always possible. Oh, sorry. So we can see the only one that really works is 1, and 1 does not simplify anything, so I cannot break this apart. This problem is done. So this is the answer I need. I need a plus and a minus here. So plus and a minus, this will be our answer for example 4, and this is our answer for example 3.